In this video, we're going to review how to determine the coordinates of the vertex from the factored form of a quadratic relation. So recall, in order to determine the coordinates of the vertex, first we need to determine the zeros. So if I look at this relation of y equals -2 times x minus 4 times x plus 6, the zeros will be 4 and -6, since these are the values of x that will give me a corresponding y coordinate of 0. The next step is to find the x coordinate of the vertex by taking the average of the zeros, since the vertex is going to be halfway between the zeros. So adding 4 and -6 together and then dividing the answer by 2 gives me -1. The last step is to determine the y coordinate of the vertex. And to do this, we sub the x coordinate into the original function. And then I'm going to evaluate each of the brackets. Since the values in the brackets are opposite in sign, I know that I'm on the right track. Now multiplying these three numbers together gives me 50. So the coordinates of the vertex are -1 and 50. Okay? Now we're going to look at a word problem where we have to determine the coordinates of the vertex from the factored form of a quadratic relation. It says, Amir sells his extreme cheesesteak sandwiches for $8 each. At this price, he usually sells 100 cheesesteak sandwiches a day. Amir is considering raising the price. After an informal survey, he concludes that for every 50-cent increase, he sells 5 fewer sandwiches. What price should Amir charge to maximize his revenue? How many sandwiches will he sell at this price? And what will his maximum revenue be? So in this example, we're not even given the quadratic relation. We have to come up with it based on the information that's given. So if we know the number of 50-cent increases, we'll be able to answer all of these questions. So we're going to let x represent the number of 50-cent increases. And we're going to model revenue because that's what we're trying to maximize. Revenue is the amount of money that you make from sales. So in order to determine revenue, we need to know the price of the item that we're selling and multiply it by the number of items sold. So revenue is equal to price times number sold. So I have to come up with an expression. If I'm using function notation, I'm going to let R represent revenue, and revenue is going to be a function of the number of 50-cent increases. We need to come up with an expression for price in terms of the number of 50-cent increases, and then multiply it by an expression for the number sold in terms of 50-cent increases. So let me show you how we do that. So first of all, we're going to look at price. And I'm going to create a table of values here to help us determine what type of relationship exists between price and the number of 50-cent increases. Okay. So if we don't have any 50-cent increases at all, or if Amir doesn't increase the price of his cheesesteak sandwiches, he's going to sell them for $8 a piece. If he has one 50-cent increase, that means the price of his cheesesteak sandwiches will now be $8.50. If he has two 50-cent increases, that means he's increasing the price by a whole dollar. So his cheesesteak sandwiches will sell for $9. Three 50-cent increases result in a price of $9.50. Four result in a price of $10. Okay. Five, price of $10.50, and so on. And I can write these as prices here. Okay. So let's take a look at the first differences to see if the relationship between price and number of 50-cent increases is linear and non-linear. If the first differences are all the same, then the relationship will be linear. If they're not all the same, then it's going to be non-linear. So to determine the first differences, we're going to subtract the first price from the second price, giving us 50 cents. Then we're going to subtract the second price from the third price. So 9 take away 8.50, another 50 cents. And we're going to continue doing that. And when we do that, we find that the first differences are all the same. They're all 50 cents. Okay, so this is a linear relation. Linear. If it's a linear relation, then we can model this relation with an equation of the form y equals mx plus b in the slope y-intercept form. Okay, we're going to let price be represented by y, number of 50-cent increases by x. To find the slope from the table of values, all we need to do is divide the change in the price divided by the change in the number of 50-cent increases. So slope is change in y divided by change in x. So y is changing by 50 cents, x is changing by 1, 50 cents divided by 1 is 50 cents still. Okay, so that's our slope. The y-intercept is the price when the number of 50-cent increases is 0. It's the value of y when x is equal to 0. So if I look at the table, the value of y when x is equal to 0 is 8. So the y-intercept is 8. Therefore, the equation that represents the price as a function of the number of 50-cent increases is y is equal to 0.50x plus 8. So now if I look back at what I had written earlier, in this bracket, I'm going to put the relation here of 0.50x plus 8. This is price. So I'm going to replace the price bracket, okay, with 0.50x plus 8. I'm going to put it over here. Okay. Now let's look at the relationship between numbers sold and the number of 50-cent increases. So numbers sold. Again, I'm going to create a table of values. The independent variable will still be the number of 50-cent increases. The dependent variable, however, is going to be the number sold. Okay, so if Amir doesn't increase the price of his cheesesteak sandwiches, he's going to sell 100 of them. If he increases the price by 50 cents, it says he will sell 5 fewer sandwiches, so he will sell 95. If he makes another 50-cent increase after that, he's only going to sell 90. 3 50-cent increases means he will sell 85 cheesesteak sandwiches. 4, 80. 5, 75, and so on. Let's look at the relationship that exists here. Calculating the first differences, I get -5 each time. Since they're all the same, this is also a linear relationship. So I can also model it in the form y equals mx plus b. I have to find m, which is the slope, and b, the y-intercept. The slope is change in y over change in x. Y is changing by -5. x is changing by 1. Slope ends up being -5. Y-intercept is the value of y when x is equal to 0. Okay, and again, these are x and y. So what y is going to be 100 when x is equal to 0. So y-intercept is 100. The equation that represents the number sold in terms of number of 50-cent increases then is y is equal to -5x plus 100. So this is the number sold. And I'm going to take this expression for number sold and put it in the bracket here. Okay, so this is actually the factored form of a quadratic relation that represents the revenue as a function of the number of 50-cent increases. Okay, you don't have to do all that work to get this expression. Okay, I want to point out some things from the question. If you take a look at the numbers, I'm going to circle them. We have $8. We have 100 cheesesteak sandwiches. We have a 50-cent increase in price. And it says 5 fewer sandwiches. Okay, so if I write these numbers out, we have $8, 100 cheesesteak sandwiches, an increase of 50 cents, and a decrease of 5 cheesesteak sandwiches. All of these 4 numbers appear here. Okay, notice the 2 values associated with price because they have the dollar sign in front go in the price bracket. The other 2 associated with number sold go in the number sold bracket. Okay. The number preceding x, okay, the 0.5 and the -5 represent the increase and decrease. The increase or decrease in price, the increase or decrease in sales. The number after x that's being added is either going to be the original price or the original number sold. Okay, so when you're modeling revenue, and I'll put it up here, if you're modeling revenue, okay, your 2 brackets are going to be in this form. This is increase or decrease in price. And this would be the original price. And then the second bracket related to the numbers sold, you're going to have the increase or decrease in sales. And then the original number sold. So it's always going to look like this. Okay, you just have to pick the numbers out of the question and put them in the appropriate places, but understand why they go there, okay, because of the relationships that we determined earlier. Okay, so now that we have the actual relation, we need to determine the number of 50-cent increases that will give us the maximum revenue. So we're looking for the vertex. So we're going to follow the same steps as the previous example. The first step is to determine the zeros. The zeros are the values of x that will give us 0 revenue. So you're going to set each of these factors equal to 0 and solve for x. Okay, so if I do that, okay, and I look at the first factor, first I have to subtract 8 from both sides. Then I'm going to have to divide both sides by half to give me the first 0 of -16. Then I set the second factor equal to 0 and solve for x. Next line would read -5x minus 100. When I divide both sides by -5, I get a 0 of 20. So an x value of -16 and an x value of 20 would give me a revenue of 0. Those are my zeros. Okay, you don't have to do all this work. You can do it like we did in chapter 2 when we're stating restrictions on the domain. Okay, so you ask yourself, what number does x have to be to make this 0, and then divide by the coefficient of x. Once you have those zeros, then you're going to take the average of the zeros to find the x-coordinate of the vertex. So -16 plus 20 divided by 2 gives me 4/2 or 2. Okay, the next step is to find the y-coordinate of the vertex by subbing in this x-coordinate into the original function. So 0.5 times 2 plus 8, and -5 times 2 plus 100. Evaluating each bracket separately. What are we going to get here? We're going to get 9, okay, because half of 2 is 1 plus 8, that's 9. And here we're going to get 90, because -5 times 2 is -10, plus 100 is 90. Multiplying the two numbers together gives me 810. Okay? So, the vertex here is going to be 2, that's the x-coordinate of the vertex, 810. But from here, this step where we calculated the y-coordinate of the vertex, we have a lot more information. From this last step, we know what the maximum revenue is. This is the maximum revenue of $810, okay? Max revenue. We also know the price that gave us that maximum revenue. Remember, this represented price. The first bracket was price. So $9 is the price that maximizes revenue. And this bracket represents the number that have to be sold to maximize the revenue. So 90 is the number sold to give max revenue. And x is the number, x-coordinate of the vertex is the number of 50-cent increases that maximize revenue. So lots of information in these steps. Okay, so back to the question. What price should Amir charge to maximize, I don't know if you can see that. What price should Amir charge to maximize his revenue? Amir should charge $9 to maximize his revenue. Okay. How many sandwiches will he sell at this price? Amir will sell 90 sandwiches at this price. And what will his maximum revenue be? His maximum revenue will be $810. Okay. So I can write that as a therefore statement. Therefore, Amir would have to sell the cheesesteak sandwiches at $9 each. At this price, he would sell 90 sandwiches, which will give him a maximum revenue of $810.